Intergalactic planetary, intergalactic, intergalactic planetary, intergalactic, planetary.
You're not taking that with you, are you? Watch this. Wow.
Excuse me? Do you have the time?
Wait, you said 8 o'clock. I'm late for work. Mr. Krabs is gonna be... Mr. Krabs.
வணக்கம்.
வணக்கம். நிக்கிறீங்க. ஏய் தம்பி, இங்க வா, சொன்னப்பா. ரொம்ப நல்லா ஊதுறிய.
Boom! Just work, Jordan.
Hey, where did we go? Days when the rains came down in the hollow, playing a new game, laughing and running, hey, hey, skipping and jumping in the misty morning fog with our hearts a thumping and you, a brown-eyed girl.
Pass finds Powell. Powell then a cook. Gonna get a cork.
You, my brown-eyed girl.
Oh, worked perfectly.
And whatever
World
happened,
Discus saw Brian in the 2
Tuesday is so slow.
Play that made it was the pass from
Gone
Ortiz to
down
Powell.
the
He threw it all the way to midcourt. And then
I took this girl out last night and we left around 12. We walked along lonely streets and got to know ourselves. I like to read, she likes to write, she likes to sleep, and I like to stay up all night.
Theoretical velocity was calculated by first finding the potential energy and then plugging in the potential energy as a kinetic energy because it should be the same if there's no energy lost by Q, the heat, or internal energy. And to calculate the potential energy, we used MGH, which is the mass of the ball times the height of the drop times the acceleration due to gravity. And we got 0.04 joules. And then we plugged 0.04 joules in for the kinetic energy, which equals half mv squared. Using this, we got the v squared as 16.677, and the v is 4.1 meters per second. That is what the velocity should be at the bottom of the hill. The real velocity was 3.02 meters per second. This is the velocity right before the ball goes into the loop where it spins around. And the minimum velocity required to go in the loop so the ball will spin all the way around without going off the track is v squared over r. And our r was 0.16 meters, and the r is the radius of the loop. And when we multiplied the radius by the g value, which is 9.81 meters per second, we got v squared equals 1.5696 meters per second squared, or meter squared over second squared. And the velocity is 1.2528 meters per second. That's the velocity required to go through the loop. And the weight at the top of the loop equals mass times acceleration minus the gravity, or the acceleration due to gravity. And the
I want you to really concentrate on me.
The centripetal acceleration over here at the bottom, or at the top, is v squared over r, and the velocity at the top was 1.42 meters per second, and that's divided, or squared, and then divided by the radius, which is 0.16 meters, and the AC equals 12.6 meters per second squared. That's the acceleration that we plugged in over here. Plugged in 12.6025 into the A and subtracted by the acceleration due to gravity, which is 9.81 meters per second squared, and we got a weight of 0.014 newtons, which is almost weightless. And the weight at the bottom was calculated the same way, except we added the acceleration due to gravity because it's the same thing. And the centripetal acceleration at the bottom is 57 meters per second squared, because we did the same thing as up here, except we had a different velocity of 3.02 meters per second. And when we squared that and divided it by the radius, we got a bigger number, which makes more sense since it didn't have time to slow down when it was going through the loop.
What in heaven's name are you talking about?
We took that acceleration value of 57.025 meters per second and plugged it in to the formula for the weight at the bottom of the loop, and our weight was 0.334 newtons. And the internal energy, or heat energy, is calculated by subtracting the kinetic energy from the potential energy. The kinetic energy equals half mv squared. And since our real velocity was 3.02 meters per second, we multiplied that by the mass and then multiplied it by 0.5 to get 0.023 joules, which is the kinetic energy. So the amount of energy lost by heat, or the internal energy, is the kinetic energy, 0.023 joules, subtracted from the potential energy, which is 0.0416 joules, which equals 0.0186 joules, and that's the internal energy.